Hello. In this video, we're going to be finding a formula to find side A that involves cosine. Now I have a triangle here that's sitting on a coordinate plane. A is sitting at the origin, so A is at 0, 0. B is sitting on the x-axis, C units to the right, so B is at C, 0. Point C is above the x-axis at some x, y value. So putting them there lets me name this length here as x. I went over x just to go up y units. Now, I can figure out some information about this triangle that I don't have labeled. First, let's talk about this side right here. This full length from A to B is C. This piece that's we've already labeled as x, so this must be the full C, take away x. I can figure out some information about x and y as well, and I'll involve sine and cosine like was suggested in the directions. So the cosine of angle A is your adjacent over hypotenuse. The adjacent is x, hypotenuse is b. And so x would be the same as b times cosine of A. The sine of A is your opposite over hypotenuse, so that's y over b. So if I got y by itself, that's the same as b times sine of A. Same with what we had with the law of sines. Now, noting that this triangle over here is a right triangle, I can find some information about A using the Pythagorean theorem. If I did y squared plus c minus x quantity squared equals a squared. Okay, and so I'll put a squared first equals, and then y squared, and instead of y, I'll put in b times sine of A quantity squared plus, and then I'll do c minus x, so c minus, and then x is b times cosine of A squared. And I'm just going to go ahead and clean this up. So a squared would equal, and then if we did b sine of A squared, that's b squared times sine squared of A plus, and then the next piece I have to FOIL. This means I'm taking c minus b cosine of A times itself, and c times c makes c squared. The outers make a negative bc times cosine of A. The inners make the same thing, so there will be two of them, so I'll put that 2 there. And then the last, negative times a negative is a positive, b times b is b squared, times cosine squared of A. Now, putting things together here, if I look at this piece and this piece, so let me reorganize this. So a squared is equal to, and I'll have b squared times sine squared of A plus b squared times cosine squared of A, and then still plus the c squared minus 2bc times the cosine of A. If I factor out the b squared that's in common with both of these, so a squared is equal to, and I'll do the b squared times, and I have sine squared of A plus cosine squared of A, and then still plus c squared minus 2bc times cosine of A. This right here we know is equal to 1. So 1 times b squared will cancel and just becomes b squared. So we end up with a squared equals b squared plus c squared minus 2bc times cosine of A. And what we have here, if you look at that first section, it looks very similar to the Pythagorean theorem. The a squared is the hypotenuse in this. The a is because it's across from the right angle, and a squared is equal to b squared plus c squared, but we have an adjustment, the minus 2 times b times c times the cosine of angle A. So in order to find A in a non-right triangle, we can use the law of cosines is what we're going to call this. which is an adjustment on the Pythagorean theorem. Here are the three different versions of the law of cosines based on whether or not we want to find A, B, or C. In the example below, I want to find B, which allows me to put the law of cosines to use. I cannot use law of sines because I don't know any angle and its opposite side both, so law of cosines is what we have to use. And basically how law of cosines works, we want to find B, so it's B squared equals, we find the other two sides, so that's 5 squared plus 4 squared minus 2 times those sides times the cosine of the angle between them, that's 75. And this is pretty much calculator work. So 5 squared is 25, 4 squared is 16, minus 2 times 5 times 4 makes 40 cosine 75. It's very tempting to add 25, 16, and 40 and then subtract the 40 off, but that 40 has to multiply first. So b squared would actually equal, and it's 41 minus 40 cosine 75. My calculator tells me 41 minus 40 cosine 75 is about 30.65. And then if I square root both sides to get B is, and I'll say approximately 5.5. Okay, and that's how we can use the law of cosines to find missing sides of a triangle. For now, we are done.